Okay, so there's our question. So the annuity formula, I'll give you that again. It is S equals, let me change the color here, R, and then a big old bracket, and it's 1 plus, and this was straight per period, so that's the R over N to the NT minus 1 over R over N, right? Like that. Now, I wanted to mention, if you use the Math Excel help buttons thing, they're going to give you a little different version. So, for Math Excel, they just write it like this. They make the R over N an I. So it ends up looking a little cleaner, but I've noticed students get confused on what the I is. And they also make the N over T just N because they're using N a little differently. So just heads up, you know, Math Excel does a little different version. I've found it's easier for students if I just show them every detail. So if you just use this, you're safe, it'll work, plug everything in, and it'll be consistent with the other formula as well, where R meant what R meant. See, the way Math Excel did is, I know they're making it cleaner, that's their desire, but now they're suddenly using N a different way, and I've noticed that's confusing for students when it's all in the same test, and N means one thing one day, and N means another thing the other day. Is confusing. So I'm just going to use the full-blown version, even though it's big and ugly, it's consistent. All right, so here we go. So we just plug everything in. Remember what an annuity is. Let me give you the big picture because we just started. Find the amount of ordinary annuity based on the information given. R is 12,500, 7% interest, compounded semi-annually for 8 years. What that means is, what an annuity is a bunch of payments into an account that's storing up, like for retirement. That's the perfect analogy, right? You put a little money in the bank, you make the same payment every month or every year, usually every month, right? And then the pile grows over time, so that in the end, it's a big old pile, right? That's what an annuity is. Annuity is a series of identical payments building up with interest, right? There's also interest, so the account is growing two ways. That on the screen, yeah, with interest over time. So that's what that's what we're doing in this section. That's how this section is different than the compound interest from the last section. Remember the last section, we would just stick some money in the bank and just let it sit. We wouldn't add to it every month, right? That was just compound interest, right? Like we took one of the problems had a baby that was born and somebody put $9,000 in his or her account on the day of birth, and then it just sat there for 20 years and grew. No additional payments. So that was not an annuity. That was just stick the money in the bank, it grows under compound interest. Just interest made it grow. But an annuity is growing because we're continuing to make the same amount of payments into the account, and the money's growing by interest. It's growing by both things, right? Whatever's already in there is growing through interest, and then we're adding the same amount of money to that account, same payment every month, right? That's what an annuity is. Okay, so there's the formula for an annuity, and so we just got to plug all that in and use all that stuff. So go ahead and let's try that. You guys have your graphing calculators or whatever your calculator? These are big old calculator problems. I'll try to show you an easier way to do these using your calculator, especially if you have an answer button. It can be pretty nice. All right, so S equals R. What is it? And of course, you don't need to memorize these formulas. You write them right on your 3x5 card. R over N to the NT minus 1 over R over N. Okay, so plug it all in. So we're going to put the 12,500, that's the R, right in the front. And then the 7%, the 0.07 in. What is always in these problems? Yeah, number, yeah. So semi-annual, what's that mean for N?
Twice a year.
Twice a year. N is 2. Semi-annual is twice a year. N is 2. N is 2. And then T is 8 years. T is number of years, like always, over 0.07 over 2. Like that. All right. So how would I actually do that on the calculator? Let me show you what I would do, guys, because we're going to have a lot of these. If I can save you some time in the calculator, I can save a lot of time of your life, because these take a long time. I would probably start right with the inside right here. I would go 1 plus 0.07 divided by 2 equals. So kind of start on the inside, do that, and then go to the power. And if you just hit to the power, it'll grab your answer from the last line automatically. So I just go to the power 16, right? I'm just doing that 2 times 8 is 16 in my head, right? Minus 1 equals. Notice how I hit equals whenever I finish a section, right? I do that because then the calculator will just compute everything, and you won't have to worry about the order and the parentheses and all that. Just say, hey, calculator, give it to me. Give it to me. Every time you hit equals, you say, okay, do it now. And then you know it's not going to mess up order in any funny way. Divided by, now, what would be the easiest way to do that? Let me just show you a trick from this class is basically pre-calculus for business majors, so let me show you a pre-calc trick. Calculus and pre-calculus can choose. If you have a fraction on the bottom of a fraction, do you know you can just flip it up and it goes upside down, like that? The reason for that is, I bet you know, you don't think you know, like think about if you had 10 over 0.07 over 2. Doesn't that mean 10 divided by 0.07 over 2, right? 10 over, or let's say anything over 0.07 over 2. Think about what that means. It means divided by, right? And remember what you learned back in your earlier days with dividing with a fraction on the right? Remember what you can do with a fraction on the right in dividing? Flip it. That's all I'm doing. I'm just taking him on the bottom going, it's just like you're on the right. You're divided by, so what does that mean? Flip it. Huh. So the fraction on the bottom goes to the right and flips. And you change to times. Remember, that's called invert and multiply? That's what everybody does in pre-calc and calc. When you got a fraction on the bottom fraction, they just flip it up. They just flip it up and multiply it. So that's the easy, quick way to handle that. Because otherwise, you got to worry about parentheses. Remember how I told you? Remember I told you if there's more than one thing in the denominator or numerator, you got to parenthesize it. Well, that slows you all down. So the quicker thing would just be flip it up. It's like a high diver. Run your videotape backwards, right? Flipping out of the water like a fish. It goes upside down. So then you just go times 2 divided by 0.07, right? Because you multiply the number on the top, you divide the number on the bottom, don't you? Now that it's flipped and come up. Everybody good so far? Finally, times that number in the front, which I kind of saved to the end, 12,500. If you do that exact sequence, it'll give you the answer. I'll do it too. All right, I'm getting, what do I get? 262137.87. What's that number? 262,000? I should have said, nearest dollar. I better read that careful. So we got to round it 262,138. $262,138 will build up in that account over 8 years. You keep making those $12,500 payments twice a year, and they're going to grow with interest. It's going to become $262,138. Is that making sense? You okay with the calculator stuff? I'm just showing you the easiest way. Rather than like type the whole thing in, because you'd have to worry about parentheses and all that, and you could get yourself messed up. Just see how I just kind of start right in the middle? I started in the innermost parentheses is what I did, right? I just did that. I did it to that power. I did minus 1. And then this flipped up, so I went times 2 divided by 0.07 times 12,500 in the front. See how I did that? I just start on the inside. And that way I never have to worry about parentheses, which is often a problem and slows you down. You got to be extra careful. I just start with the parentheses, so I don't have to worry about it. I just start with the innermost parentheses. But remember to hit equals before you do the power. If you forget that enter, then it'll only raise the 2 to the 16th power instead of the whole thing to the 16th power. Do you see the difference? That's why I keep hitting equals or enter. because it'll compute it. Then I do my next thing. Questions on that one? Not good? All right. So let's try. All right. So S equals R, same old formula. 1 plus R over N to the NT minus 1 over R over N. All right, there you go. See if you can plug into that. Crank out the answer. Type that in, I'll get an answer. See if you can get the same one. An answer on that? Is that coming out for you guys? Getting that answer okay? Any questions? Anybody having trouble with the calculator? Got all the stuff, but the calculation is just not happening? We're small enough. I can wander around and help you for a minute. Is that coming out? Here, let me. It's a lot of button pushing. Now they're going to change the game just a little bit. Same formula. So S equals R, 1 plus R over N to the NT minus 1 over R over N. Okay. But what they're giving us, they're saying find the size of the payments. So the payments, this part is the payments. Yeah, so the S, which produces 69,000. So the 69,000 is what goes in the front. That's the amount you want produced. The sum at the end. The R is what we're trying to find. The capital R. The little r is what, 9%? I can't read it now. Looks like 9%. The N, what is it? The end of each year, so just once a year. To the NT, 7 years. Yeah, it's just once a year. They're just making the payment once a year. So the N is just 1. Everybody good to there? So basically we have to solve that for R. So how can we do that? We got to divide both sides by that big mess. Let me show you an easy way to do that. So I'm going to bring it over here. I'll write it out again. So what was it again? It was 69,000 equals R, and then parenthesis 1 plus. Can I just make the 0.09 over 1 just 0.09? 1 times 7 is just 7, right? Is that good? I just got rid of those divide by 1s, right? Divide by 1, times 1. Now they're back in. But anyway, they're not going to do anything. All right. So how can you solve for R? You just got to divide by that big old chunk, this whole chunk. You got to divide both sides by that whole thing.
So there's no -1.
Oh, I lost the -1. No, you're right. Thank you, Monique. No, it can't be changing the formula, can I? So to the 7th minus 1. Like that, yeah. Then you got to divide both sides. Divide both sides. That'll get R alone, won't it? So that means you got to type all that into your calculator. Now, again, let me help you. Let me show you the nice, easy way. Don't start with the 69,000 divided by, because if you do, you're going to have a mess. I mean, you could, but you'd have to be very careful with all your parentheses. But instead, let me give you a little help. Oops, I'm kind of messing everything up here. Let me give you a little help here. I would start right in here again. I was on the calculator. Here's what I would do. I would go 1. I don't even need parentheses. Notice 1 plus 0.09. Hit equals or enter. To the 7th minus 1 equals divided by 0.09 equals. So far, so good. Everybody see what I'm doing? I started right here, right? I just went 1 plus 0.09 equals. So notice I hit equals before I went to the 7th power, right? If I don't hit that equals, it's only going to take the 0.09 to the 7th. I want the whole thing, the whole 1.09 to the 7th, right? So equals to the 7th minus 1 equals. See how I keep hitting equals when I'm at the end of a numerator, or equals before I do a power, right? Then divide by the denominator equals. I just keep hitting that enter or that equal sign, right? So now at that point, that's not the whole thing yet, but it's almost there. What's on your screen is this entire denominator, right? That's what's on your screen. That's the entire denominator. Now, all you have to do to finish this up is take 69,000 divided by and hit your answer key. It'll grab the last answer, which was that whole denominator. And then hit equals. And you should have it. Get it up here. To the 7. I'm getting 74.99. Round in near cent. Okay, so I'm getting 74.99.66. It's on the screen, yeah. You guys getting that? Doesn't it round? Oh, 6.5. You're right, 6.5. I'm rounding too far. 6. I want that penny. 6.5. Certainly Math Excel wouldn't mark me wrong for 1 penny, would it? Yeah. So there we go. Questions on that? Not making sense? So same formula, just divide. But again, just do the calculator like I'm showing you. Just start in the end. Just start with those parentheses. I always start with the inner parentheses. Just kind of work it out. Get the whole denominator. And then 69,000 divided by the answer. It's an easy way to go. Good. No questions? All right. All right, so find the interest rate. This should be more challenging. All right, so same formula. S equals R 1 plus R over N to the NT minus 1 over R over N. We good to there? Now, so go ahead and plug in what you can and see if you can identify what they want you to find. Let me give you, so you get more out of it, I think, if I give you a second. Try that. Okay, so they're saying you want 17,424 accumulated. That's what the S, right? That's the sum. That's the total of all the payments made into the big old account. Okay. To be accumulated in 4 years. Quarterly payments, 975. That's the R. The R is the payments. Everybody good with that? 1 plus little r. Oh, that's what we're trying to find. We don't know little r. That's the interest rate. That's what they're asking us for. What's the N?
4.
Yeah, quarterly payments. N is 4, huh? And then T, how many years? 4 years. 4 times 4 there. Over R over 4. Everybody good to there? Is that good? Now, how are we going to solve that for R? Graphing calculator. Way too hard by hand. Way too hard by hand. Yeah, just really. Yeah, why can't we just do it with natural? Because sometimes I say, hey, use natural log. Sometimes I don't. Remember, natural log is when the letter, which is R, is in the power. Right? Well, it's not just that, but generally that's what we've seen. Yeah, this one's just, we don't have the R in the power, but it's just hard. I mean, it's just yeah, it's crazy hard. So, graphing calculator, that's what they're going to suggest, that's what I'm going to suggest. So what do I mean when I say do graph calculator? I mean put this in as y1, put this in as y2. I'm going to go to the next screen and show you exactly. And then do the intersect between the two. So let's do that. So let me paste it here again. Okay, so I'm going to let y1, on my graphing calculator, I'm going to let y1 be the 17,424. I'm going to let y2 be the big old formula on the right side, which was the R, which was the 975, times 1 plus, now that's, the R will be my x. You know what I mean? I'll put R, but it's, the calculator uses, the TI calculator uses the big X thing, right? But it represents the R. It doesn't matter what letter you call it. Over 4 to the 4 times 4. I would just make that 16, right? Minus 1 over R over 4. So that's y2. So type that all in as y2. So you got y1, you got y2. And then you graph them. So I'll say graph and find the intersection. Graph and find the intersection. So let's do that. So go ahead and type in your y1. Go to your y screen. Type in your y1 and y2. Also, when you type in the y2, yeah, you're going to have to be careful. Yeah, because you have to type it all in, right? So let me show you with all the. Let me show you more specifically. You got to put all those parentheses in. Remember, guys, whenever there's more than one item in a zone, it's got to be parenthesized. For example, that R over 4 in the denominator, that's going to have to be parenthesized. Right? That makes sense? Well, you know what you could do? You could do the flip. Yeah, let's do the flip it up thing I told you about. You go times 4 over R. I think that's easier. Whenever you have a fraction in the bottom of a fraction, I think it's easier just to flip it up. And you're right, you multiply by the upside down, because dividing is multiplying by the upside down, right? Like that. So how do we type in y2? y2 is 975 parentheses, a second parenthesis, 1 plus x over 4 to the power of 16 minus 1, parenthesis around that all, times 4 divided by r. Or x. I guess we're going to use x for the graphing calculator thing. There's what you want to type in for y2. That's not a 0.4. That's times 4. Times 4 divided by x.
Would you have to put parentheses on the x divided by 4 since it's plus 1? If you're putting it inside the calculator, yes.
Okay, so remember what the rule is. The rule is if there's more than one item in a numerator, right? So I did do the whole numerator. This is the whole, you got to parenthesize the whole, not part of the numerator, but the whole numerator. So that's good right there. You don't need extra parentheses around the x over 4.
Okay.
Right? So I've got parentheses around the whole numerator. So it's all good. Just like that. So, am I confusing you with this? So again, the bottom of the fraction, I would flip up. When you got a fraction on the bottom fraction, flip it up, put it on the right. Just go times 4 over, not r, but x, because that's what she uses. Right, so type all that in for y2, and then hit the graph button and see what you get. So let's try that. So I'm typing it with you here. Okay, so I just typed it in, and now I'm going to go up to the Elmo finger. There we we go. Get the light on. Get the wheel focused in. All right. For my window, I just remember my window negative 10 to positive. That's just what it was on. I don't know what your window's on. I hit graph. The window? It's just the standard. It's negative 10, positive 10, negative 10, positive 10. But my point is that's no good. Because look. So don't copy my window. Look how bad my window is. See how my window, I did the standard window. Whatever window you have, it's probably just as bad. They're all bad. This isn't good. Let me show you how to find a good window. Everybody good that we're not seeing what we need to see. What do we need to see? We need to see, what do we need? Oh, where they intersect. We need to see where the two graphs hit. I just see like a part of one of the graphs. You know, I'm not seeing much. Remember what we do. Remember, I sent you that YouTube, and you memorized it and wrote it on your walls in your house, right? What do we do when the graph, this is really the crucial, this is a tool. It's not just, you know, the idea out there in the streets is technology just does everything. Why do we need to study math and science? That's just not true, right? Do it. I said, okay, do it. It's a tool. It requires skill, right? So we have to learn, what do we do to find where that graph is? Table. Remember that great YouTube? It was a discovery for me this semester too. I'd always did other things. That guy that showed that had a great idea. Hit second table, and when you do, look at the Y1 and the Y2 values. You see, oh, it's up at 17,000. Of course it is. That's what we typed in. The other one, it's at air, whatever that means, and then it's at what? Is that 134,000?
Yeah.
Or is there like another zero back there? It's really big. Whatever it is, it's gigantically big, right? So what that means is I got to make my Y window go up to be as big as this thing. Is that 134,000? So I got to make my Y window go to like 150,000. Do you see that? So that tells me what kind of window to make. Whatever Y value that is, you got to cover that. That means the graph, it's making an XY table, and the Y is going up past 134,000. So go back to your window now. Hit window and go down to the Y. Oh, we don't need Y min to be. Do you see any negative values in there? No. No, these are money. No negative money. That's my bank account. All right. Y max has got to be. I'll do like 150,000 or 200,000 or whatever you want. Yeah, maybe 200. I'll be able to do 200,000. Whatever. There's 200,000. Hit graph again. And I'm just getting the one line. Let me go back to the table. Oh, no, there it is. Whoop, I'm too hasty. There it is. See, the second one came up, and they meet like right around there. Now, clearly, I got to focus in more there. I got to see what that is in there, huh? Am I going too quick? You guys tracking with me? See how I graphed it at first, saw nothing, hit the second table, which was second graph button above the graph table, saw the Y values were up around 150,000, and went, I gotta see where they hit right here. Now I could do that. You could find the intersection right now. It'll work, or you could get a little better view. I don't know if you want to play around with the window anymore, but you'd have to take a narrower view. Do you see, guys? I need that narrow view from like -1 to +1. See how it's close in there? So if you go back to your window, you get a better view if you go -1 to +1. Remember what X is? What is X in this one? If you keep one foot in reality, your calculator, remember, doesn't know reality. It's just running numbers. You, the operator, will be a more faithful, more skilled operator if you keep one foot in reality. What is X? I mean, in the real world. What is X in this problem? The height of Tommy, the weight of Susie, the shoe size of, what is X? Go back to the formula, right? But what is it? Go back to the thing. Where's the A? Have you forgotten? It's the interest rate. Remember, X took the role. I don't know why it's not there. X was the R. Now, what kind of numbers can interest rates be? 0 to 1. They're a decimal. None of this up to +10 down to -10. It's between 0 and 1. It's an interest rate. See how keeping one foot in reality helps? Right? So X should just go from 0 to 1. That'll cover all. Right? So go back then, change your X window to go from 0 to 1. Now the Y looks like I went a little too high. Let me just go 150,000. All right, so I've got my X is 0 to 1. My Y is 0 to 150,000. I'm ready to hit graph. Whoops. It's still not looking that good, huh? It hits somewhere in there. Maybe I should make it more narrow. Boy, I keep filling. So how about 0 to 0.1? It's for 0.2 at most. 0 to 0.2.
You need to change your scale.
0.2. Yeah, you could. I don't really ever usually mess with scale, to tell you the truth. I mean, I could. What did that do? Oh, there it is. It's hard to tell where that thing hits, huh? Anyway, I'm tired of fooling with the window. I'm going to do it. Any of these would have worked, I think, for intersection. Let's just go to get the answer. How do you do intersection, remember? Second calc. Go down to intersect and hit enter 3 times. 1, 2, 3. There it is. You could have, any of the last 3, it would have found it. Because on all of them, the intersection was somewhere on the screen. As long as it's somewhere on the screen. There's our answer. What's the X, the interest rate?
15%.
0.058211. Yeah. So move it 2 places? Yeah, just a second. So let's go back. So go back to our laptop. So the X came out to be 0.058, what is it? 0.058211189. 21189. So move the decimal 2 places. 5.82. How many do they want? 2 decimals. 5.82%. That's the interest rate that'll make that money accumulate in 4 years to the amount they want. So like if you're an investor, this would be a very practical question, wouldn't it? You're like, hey, what kind of interest rate do I need? What kind of investment payoff do I need if I want to be able to make payments at $975 and have it turned into $17,424 after 4 years? You need to hit 5.82% or better. That's what we just solved. So is there a question about how to enter it in the calculator? So here it is. Here's exactly what you want to put in for Y2. Just like that. And everybody see how to do the window thing? Right? So we hit second table. And then we change our window. And the window that ended up working was Y max like 150,000. That was the main point. And X went min was 0, X max was 1, because that was interest rate. So 0 to 1 for X, 0 to 150,000 for Y. See how I discovered that using table? So that's what I hear from students a lot is they'll graph, they see nothing, they don't know what to do. So does that make sense? That's what you do. Use the table. Questions I can answer? We good? All right. So there we go. All right. Okay. So notice the words annuity due. So that's due means annuity due means payments made at the start of each period. Ordinary annuity, which is the ones we were doing all the other problems, ordinary annuity means payments at the end of each period. So that's the difference. So you kind of have to watch that. I wasn't really calling your attention to it, but if you look back, the other ones we just did, the other 5 or 6 problems we just did on annuity, all said they either called it an ordinary annuity or they said the payments are at the end. So that's normal, that's ordinary, that's that formula I gave you. This one is saying annuity due, and so that means there's a different formula. It's very similar. It goes like this. No, whoop, I always get that upside down. That's kind of messy. It's got even more mess than the other one. That's a big, ugly formula. I could take up your whole 3x5 card. So it's got a little more Not a lot more, but a little more. Another -1 out here, notice? See that one? Oh, by the way, again, Math Excel shows it a little different, slightly. But, so I'm not going to mess around. They have a little different, but I think this will be easier for you to use. So there it is. That's the annuity due. This is for annuity due, meaning payments at the start of each period. Annuity due. All right, so that's the formula we use. Other than that, it's just the same old thing. Plug everything in there. So let's do it all. Let me write it on the new screen here. Paste it in. Okay, so again, it's S equals R. What is it? 1 plus R over N to the NT plus 1 minus 1 over R over N minus 1. Okay, so let's type it in. So we're going to go, what's ours? Payments are 15,000, so that's the R. Payments 15,000. The interest rate is 6.8, so that's 0.068 over N. How many payments? Oh, annual. Annual compound interest. So what's N? Just 1. How many years? 15 years. Look at that big old mess. All those -1s and +1s everywhere. All right, can you crank that out? So again, graphing calculator or any calculator, I would start on the inside with those inner parentheses right here. And these 0.068 over 1, they're just 0.068, right? So type that in. Remember to hit enter after every step. So I'm going to type on the calculator, I'm going to type 1 plus 0.068 equals, or enter, to the power of 16. See how I just figured that whole power is just 16? All of this is just 16, huh? 1 times 15 plus 1. So it's to the power of 16 minus 1 equals, divided by 0.068 equals, minus 1 equals, times 15,000. That should do it for you. I'm getting 39.6419. What do you want? Cent? Oh, nearest cent. Okay, 0.49. What's that? $396,419.49. Anybody else getting that? Okay. Is that making sense how to enter all this stuff? Questions before I move on from there? Everybody got it down? Question, yeah.
I just have a question with the wording.
Yeah.
So the last question said at the end. Wait, like what do you mean at the end?
Yeah, so remember, this is like a retirement account.
Right.
Okay, so annuities like retirement, you're paying every month, let's say, into an account, storing up for a big pile so you can retire later. So there's two ways you could do that. You could say, I'm going to put, $100 in my retirement account every month. I'm going to do it at the start of the month. That would be annuity due, this formula. Or I'm going to put the 100 in the account at the end of the month. You might think, what does it matter? Well, it's got an extra month to earn interest if you put it in the beginning. It's going to get a little bigger. Yeah. So that's the difference. So the annuity due is, just think this way. I just think it's due at the beginning of the month. Annuity due is due earlier. The ordinary, the normal way, the ordinary annuity is end of the month. Put the $100 in the account at the end of every month. So write that on your 3x5 card, those two versions. All right. These are such messy formulas. All right, so this is annuity due again, so right there. So we're going to use the other form, the annuity due formula. So that's S equals R 1 plus R over N to the NT. Yeah, plus 1 up there and a minus 1. Yeah, there's really only an additional plus 1 in the power and minus 1 at the very back end, huh? That's the difference between the two formulas. Is that good? So it wants me to find the payment. So I'm going to solve for R, aren't I? So it's going to say, okay, do you want $10,000? You're trying to find the payment. The interest rate is 0.086. What is in? Is this every year? Oh, quarterly. Quarterly. So N is 4. This is a pain. How many? 8 years. Look at that. What a mess. Okay. Okay with that? Getting that typed in? So what I would do, guys, is I would figure out that whole right side and then take 10,000 divided by answer at the very end. Remember how I did that a minute ago? For the other one we had to solve payments for? These are a mess. Bring it over here with a fresh screen. Okay, so we have 10,000 equal to R 1 plus 0.086 over N. Oh, no, we know what N is. N is 4, right? Quarterly payments. How many? 8 years. Okay, so I would then divide by this entire ugly thing. That power is 33, right? The powers, I just always figure them out by themselves. 4 times 8 is 32, add 1 is 33. That makes it easier. So that power is just 33. You got to divide both sides by that. Boom. That'll get you R alone. Okay, so how do we type that in? Oh, that's a mess, isn't it? It's a big, ugly mess. We good to there? So on my calculator, I would start right here and here in the parentheses. 1 plus 0.086 divided by 4 equals, remember I always hit equals before I do powers, to the power 33 minus 1 equals, then remember what the denominator does? This is the, don't worry about that minus 1 off to the right yet. He's outside the fraction. You guys with me? So I'm going to flip this guy up and it becomes 4 over 0.086, right? Times 4 over 0.086, then it equals minus 1 equals, and then 10,000 divided by answer. Woo! Did you guys follow all that? All right, I'll give you a final answer here. I'm getting 215.81. Nearest cent, 215.81. Those are the payments that need to be made into that account every, whatever it is, every quarter to make $10,000 at the end of, whatever it was, 8 years. Is this okay? Getting 215.81? One of the tricky parts on this big mess is how remember a denominator and a denominator, right? Fraction in the bottom of a fraction. Remember, you flip that up, but that's before you do the -1 that's after the fraction. This 0.086/4 is part of the fraction. So after you do the whole numerator, including the -1 up in the numerator, hit equals, right? That's where I hit equals, and then flip this up and go times 4 divided by 0.086, and then after that, equals and -1. That last -1 is after the flip up, because the flip up is part of the fraction, isn't it? Everybody see that? And then the 10,000 divided by answer. 215.81, we getting that? Is that coming out? I don't see any nodding. Is it yes? Is it no? Some yes, some no. Can I help? Is that good? All right, well, if you have trouble with that, grab me after. I'll be glad. It'll probably take, 15 seconds. Just the calculator, button pushing stuff. All right. Okay. So now if the payments are made at the end of each period, what does that mean? What kind of an annuity? Is it an ordinary or is it an annuity due?
That's ordinary.
Yeah, payments at the end means ordinary annuity, right? The annuity due is the one that they're due at the beginning, right? So that's the first formula I gave you today. Which now seems so much easier. I'm not going to do the rest of it. Can I just go dot, dot, dot? It's just like the other ones. I just want to make sure you're clear which formula to use, right? They're storing up. So anytime you store up for retirement or store up to buy a house, right? Storing up is an annuity. And if it's at the end of each payment, that's an ordinary annuity. That's how it's ordinarily done. Is that good? Is that okay? Ordinary annuity. All right, so she's making at the end of each year. So what kind of annuity is this? Yeah, it's the ordinary. It's the ordinary annuity. At the end is what's ordinary. Right? So anyway, so it's the same old kind of thing, same formula, do all the same stuff. And then part B, it just changes the interest rate. It's like a redo of the whole problem where they change the interest rate. And then part C just means subtract, A minus B. The answer from A minus the answer from B, like how much more would she make with the 3% account than the 2? That's all it is. It's like 2 problems in one, then subtract them for part C. So I'm going to move on. That may get a little tricky here. All right, so Gilberto opened a savings account for his daughter, deposited $1,100 on the day she was born. Each year on her birthday, he deposits another $1,100. If the account pays 9.5% interest compounded annually, how much money is in the account at the end of the day on her 13th birthday? Okay. How are we going to do this one? Think about the payments being made. When you're first born, how old are you? You're 0, right? So when you're first born, so let's think about, she's born, the little girl's born, and she's 0 years old, and a payment, right then, the day she was born, money was put in the account, first payment was made. And then when she was 1 year old, her second payment was made. And when she was 2 years old, her third, right? First payment, second payment, third payment, dot, 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 all the way. And then when she turned, 12, a payment was made. And when she turned 13, the last payment was made. See how the numbers go? right? See the pattern? Math is the science of patterns. 0, 1, 1, 2, 2, 3. See the pattern? She's 2 years old, third payment made. So when she's 12, what payment must that be? Follow the pattern. That must be the 13th payment. And when she's 13, the 14th payment. Because a payment was made on year 0, right? Her birth, her actual birth, right? So there's one more payment than there are years old, right? Okay, what's my point in all that? Well, basically, how we figure out this problem. Think about, remember, this is all about like storing up for retirement or anything, right? That first payment that he puts in the bank on day 0 will draw interest all the rest of the way. The second payment will draw interest for the rest, the last payment will have no interest. It was put in on the 13th birthday, the day they're asking me for the total. So that's right after Dad drives to the bank, puts the money in the bank. That's why they're so specific to say, how much is in the account at the end of the day? I mean, why are they getting so specific? Because they want to be sure they're communicating, Gilberto put the money in the account on that 13th birthday day. That's at the end. So you got to count that last payment, but it's not part of the annuity because it's not drawing any interest. You tracking with me? So basically, we do an annuity for these plus his last payment of $1,100. So it's 13 years of annuity, right? Because those are 13 payments, right? Annuity due at start of each period, right? Isn't he putting that money in at the start of each period? So that's the second formula. That's the annuity due formula, right? He's putting in the money at the start of her first year period, and then the money at the start of her second year period, right? So he's putting in the money at the start of each period, all the way, even the 12, it'll be put in, it'll grow a year, but then the last is just separate. It's not part of the annuity at all, because it doesn't have any time to gain any interest. So you just add the $1,100. So basically I do the annuity formula for 13 years, and then I add the last payment of $1,100. That's what we have to do on this problem. Because normally you don't have that extra payment. Does that make sense? It's calling for an extra payment. Normally you just put it in at the start of every period or the end of every period. But he's putting it in at the start of every period and then an extra one at the end. Okay, so that's what you need to do to solve that problem. Let me go to a new screen. So that's for 13 years of payments. It's good to know. All right, so 13 thirds, so annuity due for 13 payments plus $1,100 for the 14th payment made on her 13th birthday, right? This one's the 14th payment made on her 13th birthday. Okay, so we got to use the annuity due formula, which is R1 plus R over N to the NT plus 1 minus 1 over R over N minus 1 plus 1,100. Is that good? Am I making some sense? Can I now go dot, dot, dot? The rest good then? So he's got to plug everything in and work it out from there now. The trick is that extra payment, which is really not part of the annuity. Okay. Everybody got that copy down? Am I racing you too fast? One. Okay, it'll be the last one we'll work on in this section. All right, so see what he's doing? Basically, he's starting with an annuity. He's doing an annuity, an ordinary, because, right, 14,000. Oh, no, beginning of each year. No, it's annuity due, isn't it? It's an annuity due because he's doing it at the start of each period. I didn't notice that. So it's an annuity due for 12 years. And then after those 12 years, so he's putting money in the bank. Putting money in the bank at the start of every year. Putting money in the bank. It's growing and growing and growing, like storing for retirement or something, for 12 years. And then, at the end of those 12 years, he stops adding money to it, right? He then puts the total amount, right? It's grown into a huge pile. He then puts the whole thing in a better account at 5, and just lets it sit and grow without adding payments to it at 5%. So that second half is compound interest. See how it's an annuity followed by a compound interest. That's what it is. So it's an annuity due followed by a compound interest. So annuity due, 1 plus R over N to the NT plus 1 minus 1 over R over N minus 1. So we got to do that part first. We got to figure out how big that pile is at the end of the 12 years. And then once we have the pile, then we can do the compound interest stuff from there on that pile and make that pile grow even bigger. So that's the plan. Are you ready? So let's do that. So what's the R? 14,000. The little r is 4%. N, is this yearly? Annually, yeah. N is just 1, that's nice. 12 years. I'm running out of room in a hurry here. I'm off the screen almost. There. Here's that. Big mess. So we got to calculate that on our calculator. I'm getting 232,775.7, and I'm going to leave all my accuracy. Remember when you're in the middle of a problem, you don't want to round till the end? So there's every bit of accuracy that's on my screen. 232,775.7276. That's what the pile has grown to become in the 12 years. Now I've got to put that pile in a compound interest account and let it grow just by interest, adding no more payments to it. Good. You guys getting that number okay? .04, 0.04 over 1, that's just 0.04. So you don't need to flip it up when it's just 0.04 over 1, it's just 0.04. Right? You guys see when I flip up the denominators and I don't? If it's just over 1, then that's just divide by 0.04. Right? You don't need to flip anything or do anything like that. Is that making sense? You guys able to get that in your calculator? So, and this 0.04 over 1 again, that's just 0.04. What's that whole power? That whole power is just 13, right? Just to make it easier for you, right? I would just say, look, this is just 13, and this is just 1.04 to the 13th, right? 1 plus 0.04, and this is just 0.04. Oh, wait a minute, I think I messed up. I think I forgot this other minus 1. Yeah. Yeah. 13th minus 1 equals divided by 4 equals minus 1 equals times 14, 1, 2, 3. I'm getting, how about 21, something else, 218 something?
7.75.
All right, now we're all more happy. Boy, it's a lot of mess up there. Even the teacher can forget part of it. 218, 775, 775, 7276. Yeah, is that better? You guys getting that? I forgot that extra minus 1 at the back. This one right here. All right, so now that's the pile at the end of the payments, right? Now he's going to put that pile at $218,000 in the bank, right, for another 11 years at 5%, compounded semi-annually. The total amount on deposit, no more payments. All right, so let's take that number. So now we're going to take the 218, 775, 7276. It's going to go 11 years at, what is it, 5% compounded semi-annually. Okay, so the formula for that is A equals P 1 plus R over N to the NT. Remember that was from the last section? Compound interest. So we say, okay, the amount will be the principal. That's the 218, 775, 727. Remember, don't round in the middle. Only round at the end. 1 plus R, this is 0.05 over N. What's the N here? 2. Semi-annually is twice a year. To the NT. 2 times 11, 22 up there. So I would just, yeah, you know what I would do, guys? I would just leave the answer you have on your screen and just go times the rest with parentheses. I would just take my answer that I had, the 218, because it's nice when it's still on the screen, just to not have to write it and retype it, times parenthesis 1 plus 0.05 over 2, parenthesis to the 22 power equal. And I'm getting 3, 7 something here. So 3, 7, 6, 6, 3, 8. 0.04. Okay, it's getting that, 376,000. So that account builds up to $376,000 after the compound interest growth. Well, that's it. Bunch of messy formula problems. Next time we're going to do more. We're going to do them backwards. We're going to take a big pile and let it break down into little payments. Instead of building up, we're going to tear down a pile. We're going to do it the other way. So that's